To demonstrate sensitivity analysis, I will use the investment problem from chapter 3. And as you can see in this slide, the investment problem was about investing $750,000 in bonds of 6 companies. Here are the companies: Acme Chemical, Dynastar, Eagle Vision, Micro Modeling, OptiPro, and Sabre Systems. Here you have return, annual return from each investment, years to maturity and rating. We're assuming we just want to maximize expected or average annual return. So and there were additional restrictions: no more than 25% invested in any single company, at least 50% should be invested in the long-term bonds, those with 10-year maturity or longer, and at most 35% in low rating bonds, 3+. So the model here you see has 6 decision variables. For each company there is a decision variable saying how much money is invested in this company, measured in dollars. We maximize the return, and as you can see, return is just calculated by multiplying a percentage return times the dollars invested. So our return is also measured in dollars, right? How many dollars of return we have per year. And then we have constraints saying, right, that whatever we invest, the sum of all investments must be equal to 750,000. We have at least half is invested in long-term, and long-term investments are investment number 1, 2, 4, and 6. You can see 1, 2, 4, and 6 have 11, 10, 10, and 13 year maturity. Then we say with those high high rating, in this case high means bad rating, 3 and 4, right? Investments number 2, 3, and 5, Dynastar, Eagle Vision, OptiPro, we can't invest more than 35% in those. And then we have minimum investment in each bond is of course 0 in this case. Maximum is 25% of all the money. Now how do we model this in Excel? So I've prepared here an Excel file which has the data copied. So we see the 6 companies, the returns, years to maturity, and rating. And now we would like to create a model. So we need first we need the decision variables. I will put here dollars invested. Right, this will be my decision variables. 6 decision variables. I need to maximize the return. I have the annual return, so the actual return will be some product of this table with this table. It's a good idea to put it here, right, or somewhere below. So I will have total return, right, total return, or let's put it here, total return, bold, will be some product of returns and dollars invested, right? I can use the F4 here. I might be able to copy this later on. I fixed the reference to the variables, not to the parameters. Parameters might change if I copy it somewhere else. So of course now the return is 0, but if I invest, let's say, $1,000 in this, I will have $86.5 return. Is that correct? Yes, it is, of course. 8.65% from $1,000 is $86.50, right? So our function is working. We have the variables, we have the objective, we still need the constraints. In the constraints we want to say sum of invested funds is equal to 750, so we can put total here, and then we can say available. Let's put it short, avail. I will have a total here, and that's a simple sum here, right? And available is 750,000. So that's this. These are 2 functions. Let me mark them with color for functions. We have the first constraint, we still need the second and third constraint. Now a nice way of putting the second and third constraint is putting an indicator, right? We need 10 plus maturity and we need 3 plus rating, right? Now I can of course do this manually. I can say an indicator says 1 if there is a maturity 10 years or longer, or 0 if it's not. So I can start putting 1, 1. This one is 6 years to maturity, so I can put 0 and so on. But there is a nicer and automatic way. I could use an if function, if, and then say this is greater than or equal 10, right? The maturity is 10 years or longer, then value is 1, otherwise value is 0. And I can see that if I do this and I copy paste it down, I get the correct indicators, right? I can now do the same function here. If rating is greater than or equal 3, 1, otherwise 0, same thing. And you can see rating is poor, 3 or 4 for Dynastar, Eagle Vision and OptiPro as we wanted. Now that we have those indicators, the sums here, right, instead of writing the actual x1, which is this, plus x2 plus x4 plus x6 for the second constraint, I can simply write a sum product, and actually the same sum product that I have here, I just copy it, right, from the total return. I copy the sum product and paste it here, and you will see that it is correctly taking now these parameters, because parameters were not fixed references but relative, right? So it takes the column of parameters and multiplies each parameter by a respective variable and adds everything. So we're now getting the sum of funds invested in 10-year or longer maturity, and now we want this to be at least, so in this case I need to remember that this is a minimum, right? I will put minimum, and that is 0.5 times the total. Okay, so I will just put for myself, this is minimum at least. Now for rating, it's a similar function. I can again copy paste it, or instead of copying and pasting, you can actually drag this little square here to the right. It works the same way as copy and paste, and you see again it's the sum product correctly calculates the total amount invested in rating 3 or 4 investments. And you see in this case of course the sum is 0 because now we have only $1,000 invested in Acme Chemical, and it is not included in this constraint. It is very good investment according to our rating. So now, and I want to say this is maximum, right? I need maximum, let's justify this, and I need this to be maximum 0.35 times the total. Okay, now I think I'm ready to enter things into the solver, so I will go to the, it's a good idea to select the return, the objective function when you go to the solver, because in many cases, when you first time, in many examples many times in Excel solver, when you select the objective function and start the solver for the first time, it is automatically entered as the objective function. Now we want to maximize, this is correct, by changing dollars invested, and then add the constraints, which are total invested must be equal to 750. 10-year maturity must be at least 375, and then this must be at most, right? 3 plus rating must be at most 262,500. Then we also want to say all amounts that are invested are greater than or equal to 0. Oh, and I forgot about the constraint maximum amount is 25% on 750. Let me close this, and actually let me redo this. Let's move those values lower, and instead of saying available, I will say this is equal, right? This one is greater than or equal, and this one is less than or equal. That will help me correctly enter those formulas. So let's see once again. And I need the minimum or maximum amount in each. So max, I need this to be equal 0.25 times 750, and I press F4 to fix this reference because I need this now computed here. Now notice what is important here is that to realize I'm not marking this with the green color like this, even though there is a formula here. However, this formula is not calculating anything dependent on the variable, right? This is just taking 750,000 and taking 25% of it. And 750,000 for the purposes of this model is a constant. So 25% of this is also a constant. The model will assume, the solver will assume this is a constant value. Same thing here, 35 or 50% or 35% of a constant is still a constant. Also these, even though there is a formula if calculating whether this is a long maturity or not, putting 1 or 0, this is a constant, right? We could have entered it ourselves, but we can automatically determine this constant value based on this number and the same rating based on these numbers, right? So there are two types of formulas in this model: those that depend on variables, like the total that is invested, or the total that is invested in long maturity and so on, right, or return. These are formulas that depend on variables, and these I have to remember that they will be changing. And there are formulas that depend on only on constant values. These formulas, for all the practical purposes, I could have put constant values there, right? I could have written myself 187,500 in this place, right? Remember that for the solver, when we go to the solver, we can assume these are constant values, and we don't have to worry about them changing, right? This is important. It is important because you see, for example, I'm using a sum product here in this place, and this sum product is multiplying those values by those values, but only those are variables. These are constant values, right? If they were actually formulas depending on variables, I would have a nonlinear function. I would be multiplying something related to a variable by something related to a variable, right? But in this case, this is a constant, even though it is determined by a formula. So what was still missing? Let me check the constraints. I have the constraints. This equals this. That's correct. Okay, I have a constraint change. The 10 plus maturity total invested must be at least greater than or equal 375,000, and I have the constraint the total invested in poor rating less than or equal this maximum amount, 35% of the total. That's correct. I still need to say, I already have minimum 0. I want to say variables are maximum this. And again, I'm saying this less than or equal, this is a constant really. Okay. Click OK, uncheck this checkbox, change to linear programming problem, click solve. Hopefully everything is correct. Solver found a solution. Let me check answer and sensitivity report, so that here at the bottom they will appear in a moment. I click OK. We see the solution, we see how money is invested, we see that we invested in 5 out of 6 funds, we invested as much as we could in 3 of them, number 3, number 4, number 6, nothing in number 5, some amounts between minimum and maximum possible for the first 2, and then we can see we have the sensitivity report and that we have the answer report, right? So this is the solution we solved. In the next episode, I'll show you what you can learn from the sensitivity analysis report.